Okay, welcome to my remote talk on tackling component state reactively. The technologies that I will use is Angular and RxJS, but you can most probably map these concepts also to other frameworks like React, Vue, and for example also Svelte. Good, let's start with a quote. The quote is, if you stick to the paradigms of object-oriented programming, the patterns appear naturally. Why did I put it here? I stressed the bold part here, patterns appear naturally. What I want to stress is that they did not invested a lot of energy to come up with those patterns. They just stick to the paradigms of object-oriented programming, and the patterns appeared effortless, naturally. With this in mind, I want to start and give you a very quick overview of some general terms. So the first term or the first terminology section that I will discuss is layers of state. And if you look at this diagram, on the very left side you have server state. Server state is the most persistent state. It lives on a relational or object-oriented database or any other storage that you can have on your server, and is like living way longer than any other client-facing application would need this data. On the client side, we have two different layers. I mean, we have way more layers, but I only named two of them, the persistent state and the ephemeral state. And for persistent state management in Angular, we have here a couple of famous libraries. NGRX, one of the most famous and most used libraries in the Angular ecosystem, created by some really smart guys, and also parts of the Angular team joined these projects. Then we have Akita and NGXS. All of them are really great state management frameworks and do a great job in managing the persistent, the global state. I start to present again, and then I show you the diagram: persistent state, relational databases, object-oriented databases. Then we have on the client side persistent state, ephemeral state. I already named the libraries, and now I will switch to the right part, ephemeral state. Ephemeral state is this topic of today's talks and all the derived architectures from it. What does ephemeral state mean? So ephemeral state is a specific type of state in your application. If you are already used to global state management tools, like one of those that I mentioned before, I guess also Redux is a very common term for global state management, you may know that they exist on a very top level of your whole front-end application. As a front-end application, at least nowadays, is built with a component-oriented frameworks. We also have component state. We have states that only lives in one of those subcomponents, and this is marked here with the yellow helmet. Let me give you a little bit more terminology and categorization so that you can really see what the difference between global and local, or global and ephemeral state is. I have three different questions that I ask about state. What is the accessibility? What is the lifetime? And what are the processed sources of state? If I first start with accessibility, what does accessibility of state mean? So if you look at this diagram, we see this is the accessibility of global state. We have global accessible data, many different components, child components, inject global state over a service or reach it in another way, and they basically share the same state slice. They share the same data over multiple parts of the whole application. Versus local accessibility is not that much about sharing global state, but way more about maintaining an isolated piece of state in your components. You may combine certain layers that I marked here on the upper part of the dashed line, the global state, parent components, the URL, and other services. And in your client, in your component state, marked here with the yellow helmet, you combine those. And important here is you don't share this state in between multiple different components. It is really very locally. The next thing is the lifetime. If you think in these Redux concepts, the lifetime of those states is always the lifetime of the app. So as long as your app lives, this is also the duration, as long as your state lives. It is globally, it is a very static lifetime. If we compare this to the state inside of a component, a directive type, or a service, we see that this lifetime varies a lot. And if you want to get a better idea of really dynamic lifetime, you can think about the push pipe and displaying part of my state in the template. So now imagine you have an if condition in your template, and this if condition is only true for a very short amount of time. This is, I guess, a very good example of really dynamic state that has a very short and dynamic lifetime. Is processed sources, and processed sources means which sources do I process to generate, to aggregate state. And if we think about the global state, we mostly process global sources. Global sources are, for example, REST APIs, WebSockets, the browser plugin, and I combine all those sources together in my global state management. Let me name this a Redux word again, so that you know that I'm talking about a Redux state management, which is globally accessible. I marked here this dashed line in pink. So everything above this dashed line is global. Everything under this dashed line is local. What sources do I process for local state? As you can see here, of course, I reuse slices from the global state management, from the global state or from other sources. Can I help you?
Yeah, you can continue.
Yeah, I will wait until you're finished and then I will continue.
So just wait for a few seconds. So. Yeah, we can continue.
We can continue. Okay. Which laptop should I use? This
one only.
Okay. Very good. So, yeah, I talked about local processed sources for local state, and for sure we see that we use or reuse slides of our global state, of other parts of other services, but way more interesting, we process sources that are derived or that live in the local layer of this component. I have click streams, scroll streams, I have some timer, maybe output binding from a child components that I need to process this local state. And this is basically a very good overview of these three topics and how you think about global and local. So if I start the presentation again, go down. Now I start with some problems, and I don't want to dive into all those problems because I want to show you a little bit more of live coding, but just that you know, there are some problems that you need to solve with sharing work and instances, subscription handling, late subscribers. You have to make sure that you have hot composition and that you can also interact with all the state slices in a subscription-less way, because maintaining subscriptions is always a pain in the ass. And what I do with my approach is I completely get rid of all those subscription handlings at all, so you will never see the word subscribe in any of my code examples. Let's quickly start with timing. If we look to an Angular component, for example, we have certain life cycles, a lot. If you think this is complicated, let me show you a hello world example where I just fetch some data from the global state and display it in some component. It looks like this. As you can see at the very top line, we have an infinite number of life cycles, and in the end I just displayed a tiny amount of data, so just that you get a better clue of how complex all those things are in the front end. So quickly, let me talk about this subscription handling part, because this is one of the essential parts of this. It's not a library, it is a technique of this technique. So when we want to handle subscriptions, we can think of something like this. We subscribe whenever we start a component, and we unsubscribe whenever we destroy the component. And we have the proper lifecycle hooks here. On the left side here, I'm not sure if you can see my mouse, but here I have a common pattern. I have a subject in this part here. I subscribe to my subject, and when the component gets undestroyed, I next this value, and then the take until operator is doing its magic and unsubscribes from this subscription here. Now the interesting part is that this is not a component but a service. Also a service has an ng-on-destroy lifecycle hook, and what I can do now is I can reuse this service in a component on the right side. The cool part on the right side is I used providers, component providers here, so the lifetime of this service is not a global lifetime, but it is only here as long as the component is here. So the lifetime of the component is equal to the lifetime of this service. If I now use the subscribe method of this service in my component and I initialize a subscription, the unsubscribe happens automatically when my service or my component in particular gets destroyed. Next is sharing work, and you maybe know that subscriptions are cold, so every subscription to a observable is a unicast. What we should consider is multicasting several things. For example, multicasting instantiation of objects and multicasting different slices of your stream. To get a quick overview why this is important, the black gears here is a symbol for work that is needed to be done. And on the left side where you see unicasting, you see that we have a lot of work to do, versus on the right side where we have multicasting, we only fire or run this work one time and then we reuse it later on. Some examples that I will skip, and then I will go right to the next example, late subscriber problem. What is the late subscriber problem? As several sources are hot, which means emitting all the time, and my components are instantiated and destroyed over time, then maybe can miss values that are before or after the subscription inside of my component. So if you look at this snippet of code here, I take state from my input binding and then I display it over the async pipe in the template state pipe async. And the problem here is no values will show up. Why is this the case? Because I'm too late. My at input binding is firing way before my async pipe is subscribing in the template. And this is the reason why I don't see the emitted values. So what I can do very quick, if you look at the problem here, this white circle is empty, and what I can do is I can use a replay subject marked here. And this replay
just wait a second. We have got a question that what is a pipe? So why we use pipe?
Can we make a question section somewhere in between? Maybe let's make now a very short 5 minutes or 2 minute question section, and then I can continue with the presentation, and then we have another question, because otherwise it will be very fuzzy and a lot of interruption will happen in the As you know, I'm a confused person and I will lose the focus. So I will answer the pipe question here, and then I will go back to trying to be focused and with structure, which is not the easiest job for me. And if we try to keep the questions blocked, then it's a bit easier for me. So what is a pipe? In React, we can render state by using the setState method. So when we call the method in our TypeScript section, we retrieve the state and the component gets re-rendered. In Angular, we have a very cool and different approach. We could also go with something similar than setState, but in Angular, we can put something that we call pipe in the template. And here, I'm not sure if my mouse is visible, but this word here, async, is basically a pipe. What is this pipe? This pipe here is specified over this pipe symbol here and then the name. And in this pipe, I will retrieve the value, and whenever a new value arrives, because we use an observable is push based, the new value will get pushed into this pipe, and then the pipe calls this set state method that you would have in React, and in Angular we call this set the method to render the component, mark dirty, mark for check, or detect changes. There are several methods that you can use. All of them re-render either the whole application or just this very component. And in this case here, our async pipe renders the component that we are in here. Was this a good explanation for the question?
Yeah, that's great.
Okay, maybe you collect the questions and I make a small break before the live coding. Is, I guess, a good point. Otherwise, feel free to interrupt me, and always used to be confused, so why not being confused again here? Where was I? Okay, so the value was not rendering because we used a subject. I'm not sure how familiar people with Rx are. Unfortunately, this is not a beginner's talk, but let me quickly tell you that a subject is something that you can call next on it, and then it will send a message to all the interested people. And there is a special type of subject, which is the replay subject. And the replay subject, basically, when you subscribe to the subject, it replays a number of last values. In my case here, I specified the number of replayed values to 1. So when I subscribe to this subject, I get the last value replayed. And this is the quick fix to this problem here, because even if I'm too late and I subscribe to it, the last emitted value will get pushed to me. Maybe this is not the best choice for a solution, because it is just a quick fix, and I wanna mention several caveats here. First, you see we have this purple circle showing up in our template, but what are the caveats? The first caveat is you push workload to all the others. If you want your component to render state, everybody else that you retrieve state from has to implement the replay subject and replay at least the latest value. Maybe you can force all your team members to do it in this way, but what about third-party libraries? You cannot force third-party libraries to adopt to your theme here. So this is the first drawback, the first caveat that I want to mention. The second, way more important caveat is that your state composition is still cold. And this is very tricky, and not a lot of people consider this problem. If you have a source which emits a state and then you process this state in some way over operators, the processing of this state will get triggered by the subscription to the source, which is not cool because you will lose values. Let me show you that if I just use a replay subject or share replay as an operator, I will end up in broken state, or let's say in incomplete state, and I may miss values that are emitted before the moment when I subscribe. Maybe you will say, oh, well, the subscription happens immediately when the template is ready, and I could move this subscription into the ng after few init lifecycle loop or whatever. But let me tell you that you can also have if conditions in your statement that make it activated way later in time. And then you will lose a lot of values that you should process. What I suggest is that you use hot composition, and one way to achieve it is we can use the publish replay operator here, and in the latest versions of Rx we will also have creation operators of this publish and share operations, which is a pretty cool thing if you ask me. So this is the way how we solve this problem. And the last very important thing before I will do a quick live coding session is subscriptionless interaction. So whenever you call subscribe, you maybe know that you can face a lot of problems, race conditions and other stuff that you have to deal with. Or for example, memory leaks if you don't unsubscribe. And this is a pain in at least my ass. So what I came up with is a strategy where you don't write subscribe at all. And if you don't write subscribe at all, you don't need to write unsubscribe at all, right? Makes a little bit of sense. So let me show you how I did it. If you take a look at some imperative code here, we have a state service and then we call it a dispatch method. And this dispatch method is basically a setter. I call set state, I call set whatever. I dispatch a method imperatively and I dispatch or I set this certain value here, count to 100 in my state management. So the problem is, if my source now is a stream, I cannot use this setter, because if I use this setter, I have to subscribe to the stream. Whenever the next value is emitted, I have to call this next value, and then I have to call unsubscribe. So setters are not really good. Oops. And let me show you the amount of code that I would write for either the router state, a global state, or an input binding. Let's say my component is using all those 4 different states and composes them. I would have to subscribe 3 times, I would have to use the take until operator 3 times, and I would have to use the destroy subject 3 times. And this is really a lot of code to write. Let's take a look at the problem. We have observables and then we break the reactive style because we use setters. We call subscribe, which means we stop reactive programming, and then we call next on our subject and emit this next value. All the orange boxes that you see here, I hope you can see them, are here to process state, to merge state slices together. And the pink line here is the break of reactive programming. So what is the solution? I suggest using a higher order operator that is called merge all. You can also use others, but this one works for most of the state management use cases very well. What merge all is doing is, instead of retrieving single values, it retrieves a stream of streams, an observable of observables, a higher order observable. And this higher order observable basically takes those observables and subscribes internally to those observables and forwards their values. For example, here I take the router state, I subscribe internally, and all the router state emissions are emitted and merged to one output. Same with the global state, same with the component state or input bindings. And then I can forward these observables to my accumulation, to my scan function, and then I can compute the state without calling subscribe. And this is really, really a cool trick that you should keep in mind, because it's not only good if you're a library creator, but also if you use and compose certain streams on your own. In the end, the outcome looks like this. Instead of writing 12 lines, we write 3 lines of code here. we call the connect state method. We pass in a whole observable, and internally merge all and scan is used. It's a really cool trick that I would recommend everybody to take a look at. And I also will use it in my live coding. So what I came up with, the topic of this talk is state management, ephemeral state management, is around 15 lines of code here, about the 15 lines of code here and a very slim API. Let me show you the API because we cannot read these small characters here. The API is set state for imperative programming and connecting imperative code to reactive code. And then we have connect state. This is the proper way how you should combine streams together. And then we have hold, effect, and select. Connect state is the proper way. As I said, hold effect is whenever you have code that runs and emits a certain value or action that is not rendered, I call it side effect. Rendering is also a side effect, but for rendering, I have specific solutions here. Everything else is considered a side effect. And then you have select, and select is basically here to select, to retrieve state from my tiny service. Now I would start with my demos, but I guess this would be a perfect moment to answer questions. So the moderator is not here, and I have no clue if there are any pending open questions. Could you help me to get questions? To get the questions to answer. Now it's question time. So, what questions were asked in the meantime?
So I have a question. I have a few questions for you that based on observable. So do we need to subscribe every time for the RxJS observable?
This is a very good question and also the essence of my solution. Mm-hmm. Yes, if you are interested in values emitted from an observable, you have to subscribe to this observable. Mm-hmm. And this is done by calling .subscribe, and then you pass a callback function that should happen when you subscribe. As I said, it is a lot of boilerplate, a lot of code to write, a lot of stuff to consider, because if you not unsubscribe from the state when you're not interested anymore, you most probably introduced a memory leak. Okay. So my solution here with the merge all operator solves this problem, and you just hand over the whole observable, and then subscription happens internally, and you don't need to care about subscribe, nor you need to care about unsubscribe.
Okay, so basically for the memory leak, we don't need to unsubscribe. So just put subscribe, then API call, it will respond to array or something else, some variable.
Yes, but then you need to unsubscribe if you're not interested anymore. Let's say you subscribe in a component. Whenever the components gets destroyed, you need to take care about unsubscribing from your subscriptions, otherwise you introduce the memory leak.
Okay, that's good. So, and about the architecture, so basically you told about some new components, about some new features, some new components about that.
Yeah.
So what is the best way to architect our Angular project? So basically having an API call. So both projects are separate. The separate project of API and the separate project of Angular.
Okay, so you asked me how should you implement fetching data from a REST API endpoint. Is true? So I talked about two different layers, global state management and local state management. And if you make a call to your REST API and it is a fetch call, for example, you may want to maintain this fetched data locally to not refetch it over and over again. You basically want to introduce a small caching layer to prevent overfetching. Overfetching is one of the most common problems that you can run into when using client-side applications or when generating client-side applications. So what I would suggest is introduce a separate layer, global state management, to do the fetch call, store it there, and then forward it to your component. And in your component, you can use tools and techniques that I suggest here in the presentation to merge this global state into the local state that you want to maintain in your component.
Okay.
Okay?
That's good.
Any other questions?
So yeah, so there is no question anymore. So I think your presentation time is over. You are showing a demo.
Yeah, is the presentation time over or?
Yes. So we have 5 minutes. So if 5 minutes is possible.
5 minutes?
Yeah.
I can show, I will not do live coding, but I will show some codes that you can get a better clue of how I think about this state management thing. So I created a small service, as I said told you before, and this small service here is called local state. This class, I extend this class. Maybe inheritance is not the best way to share knowledge.
So your desktop is not being shared.
My desktop is not sharing, okay.
So let me share the desktop.
Yeah, if you can configure it, this would be cool.
Yeah.
Maybe end.
No. If end, then webinar will be.
Webinar will be ended. Okay, maybe not ending the webinar is a good idea. Okay. Is my screen now visible? No. Let me end the presentation here. You see? And now I go back to here and I click.
One second.
Share. I click here. No.
It's fine.
Now we have, now it is working. Good. Yeah. Perfect. So I have this service. I can extend it or inject it. Maybe extending is not the best way, but I guess it's easy to grasp. And then I use this service. I have input bindings, and let me switch to here. And I can call set state for input bindings. I can say, oh damn it, give me a second, component. So I can call for input bindings set state and set the whole state. I can connect streams like fetching global state, your HTTP request. I could directly use my Redux store and connect to a certain state slice locally. And I can hold also effects and other state slices. Important here, you don't see any .subscribe call anywhere, but it is also working.
Okay, so it is calling the API?
It is calling the API, and internally in the connect call, I call the subscribe. So it is hidden away. You don't need to care about subscription and unsubscribing at all. I have a repository that maintains this small service that I call local state service. Another cool thing, if we have this connect method, quickly before my time is over, is most of the people are used to pass single values. So if I show you a component, most of the people are used to have an input binding, then have the observable here and call the pipe async to subscribe to the observable. And whenever the observable emits a value, I apply this value to my input binding and I trigger change detection for every new value that arrives. So with my new technique, you can also do following. You can pass the observable directly to the input binding, and then in my component, instead of using set state here, I can say connect state. And instead of passing a single value, here I have an observable. I have an observable of numbers. It's very hard to type on your keyboard because it is not my keyboard layout that I'm used to, but yeah. Here I have an observable of numbers, and then I can say, okay, I have this observable of numbers. The state slice that I want to update with this state is called refresh interval, and I can forward directly the observable to this state. So now you might ask, how can I solve this if condition here? Well, as we have observables, I can just add a pipe, and I can use the, oh my God, what is happening here? Okay. And I can use the pipe filter, and I can move my if condition into the filter pipe. And I can basically refactor this imperative code in a very nice way to something useful. Let me just try to fight with your keyboard here. So if I move the condition into the if operator, Control V for paste, and I make a proper import, I refactored everything to an observable way of doing it. What's the benefit by passing the observable itself to the input binding? It's really cool because I have only one change detection for the passed observable, and then values inside of the observable will not trigger another change detection. Only, for example, if I want to render them. And this is pretty cool if you have these values that you pass through multiple layers of input bindings. You can save a lot of performance there. Yeah, I would have way more live coding sessions, but as the presentation time is over, I don't want to waste other people's, or I want to respect other people's time, and basically make a quick roundup here and ask you if you have any final questions. If not, I would be considering my presentation as done.
Yeah. So the last question is that why right now the Angular 9 has launched out. So why to go with Angular? And why not to with React or some other framework? So can you just explain about that?
You wanna explain me the year-old discussion of Angular versus React versus Vue versus Svelte?
The moreover is about that what's new on Angular 9 and why to implement Angular framework.
Compared to React or what?
Yeah.
So either I can explain why I use Angular versus React, or I can explain new parts in Angular Ivy, but I'm not sure if I can put it in a meaningful way to answer those two questions in one.
Okay.
Ivy is a complete rewrite of the rendering engine, and Ivy did not really touch the ecosystem of, we have a router, we have forms, we have an HTTP client, we have all the different parts of this framework. It did not touch it, it touched the internal parts, the rendering parts, the parts how we can write Angular code, and moreover, Ivy rewrote the way how Angular gets compiled. What I think is really cool, and I did not mention it online, Ivy introduces the majority of this thing is private and private API, but Ivy will introduce a new rendering API, and I'm incredibly excited about this new rendering API. It will enable me to write fully zoneless applications, and I can write like a more React-like way where I can just call a function and then my component gets rendered. And this is, I guess, the really cool part of this new rendering API. And if you take a look at the source code, you will see methods like mark dirty, theta mark dirty, theta change, theta schedule change, theta apply changes, and so on and so forth. And I'm really eager to show those new API calls in my next presentations. I will call them zoneless Angular applications with the new with Ivy's new rendering API. This is, I guess, a lot of information about Ivy and this stuff. I'm not sure how I should compare React to Ivy. This is a funny question for me, and
no, because everyone needs to compare whenever they are developing an application, a new application.
Yeah. So React, the core of React is just the rendering engine, like the virtual DOM and rendering of this stuff, and then you have to use libraries for forms and libraries for the router and so on. If you want to make a quick application, you can start over and use React. If you want to do like a more enterprise scale, I would say previously I would answer this question with then it's the time to choose Angular, but nowadays we have tools as NX Workspace, which serves a out-of-the-box setup also not only for Angular, but also for Vue and React projects. And I'm not a React expert, but a lot of React users told me that, hey, you have to use NX Workspace to create React projects. It is way more structured, way more out-of-the-box profits there. And I guess at the moment, it's very hard to say this framework is better than that. I guess it is personal taste, and you should pick what you already know because then you are faster.
Yeah, so in the end, all frameworks are good. It depends upon your requirement.
Yeah.
What's your requirement? Go with that framework.